All right, to finish up what would be lecture 4, we want to look at what to do when we want to estimate the standard deviation and variance from group data. And so I'm going to give the formula, and then we'll put that into perspective. So we have the standard deviation, which is going to be the square root of the sum of the deviations of the sample. This is a sample distribution, as you should see by the fact that I'm using an S, not a sigma, squared, times the frequency. What we do with a lot of estimations is we'll bin things into frequency bins, and then use the frequencies coming across. And so when the frequency distribution has classes, remember we estimated the mean by using the midpoint. And so we could say that the mean is the sum of x times f, with this being the midpoint of the bin divided by the number of samples. And so this is what we would use in constructing for finding the mean for the standard deviation. And usually we do this when we have group data. And so what we can do here is, instead of processing every individual data point, we process the frequency of how many times it's repeated in a particular bin. So for example, using the book's example of 50 households, households, and the number of children. And so if you look at the data set in the book, it's 1, 3, 1, 1, 1, 1, 2, 2, 1, and so on. We could add up every one of these and find the data. Or we could recognize that the household has 0, 1, 2, 3, 4, 5, 6 children, but no more. And so we could count the frequencies, which were, there were 10 households with 0, 19 with 1, 7, 7, 2, 1, and 4. And so adding up x times f, so 0, 19, 14, 21, and so on, and dividing by n, which was, there was 50 in this case, we get 91 divided by 50, or 1.8. The average child per household is 1.8. Well, we can use this then to find x minus x bar, which will give you negative 1.8. It's actually 1.82, so we'll be a little more pedantic. Maybe 0.82, 1.18, 2.18. Oops, let me get my lines straight here. 3.18. Let's see, 4 gives me 2.18. Let's see, that's 0. That's 1. That's 2. That's 3. I'm missing one in here. What did I do? 0, 1, 2, 3, 4, 5, 6. Good. So 0 minus 1.182 is this. 1 minus, right? 2 minus, 3 minus. Oh, I'm missing the positive one. That's, get that here. Positive 0.82. Oh, 0.18. Said it right, wrote it down wrong. 1.18, 2.18, 3.18, and 4.18. Notice these go up by 1 because my x values are going up by 1. And I can see where my mean is in here. So my deviation follows a nice pattern here. So my deviation squared, 3.3124, 0.6724, 0.0324, 1.3924. Again, calculator will be our aid, and we'll see how to do much of this stuff in Excel, but I'm taking the values I found in this column and I'm squaring them. And 17.4724. But I can't use this to find my standard deviation because I have multiple values for each one of these. So I need to do I need to do the deviation squared times the frequencies. And so I had 10 of these, so 33.124. And so I'm going to multiply this times this. And I'll do this for each one here. 0.2268, 9.7468, 9.5048, 10.1124, because there's only one of them, right? And 69.8896. And so if I sum up these frequency multiplied, I get 145, sum of xi minus x bar squared times f. I get 145.38. But my s squared is going to be the 145.38 divided by 49, because I had 50 data units, or my sigma. Let's just do my standard deviation, will be the square root of these, which is 1.7. So the standard deviation is 1.7 children. And so when we have group data, when we have a lot of things coming across, we could go through and do each 50 of these one by one, or we could group them by frequency, and then do the frequency times the deviation squared. And this becomes the easier calculation. And the same thing happens for estimating by midpoints of classes. There's one other thing that we want to use here, and this is going to be how we can compare two data sets. And so if we have all of the heights of a basketball team in inches, 72, 79, 70, 69, 77, and 73. And then we have the weights in pounds. Now this data is paired, and in Chapter 9 we'll learn how to deal with paired data and how we can look for any correlations that might be coming from this paired data. But for right now we can treat this as two separate sets of data, and we can look for any standard deviation between the two different sets, and we can compare. But what we have to do is we have to look at, let's see, this will be height, so I'll put h, and this will be weight. And so the mean of the height is 72.8 inches, and it has a standard deviation of 3.3 inches. Now I'm going to put the units here. And what we can do is we can make something that does not have units. And we're going to call this the correlation of variance, coefficient of variation, I should say, coefficients of variation. And it's going to be the sigma divided by mu. And what this will do is this will take the 3.3 and divide it by 72.8 inches. But inches over inch cancels out, and I get a pure percentage. I get a 0.045 or 4.5%. And this is for the height. And so I can say that there is a coefficient of variation of 4.5% for the height. Well, if I go back and I find the mean of the weights, I find that the weights are 187.8 pounds with a standard deviation of 17.7 pounds. But I can't compare pounds to inches. But if I take the coefficient of variation for the weight, and I take the 17.7 and I divide it by the 187.8, I get 0.094, or approximately 9.4%. And we can say that the weights have more than twice the spread, right? Or at least twice the variation. And so the weights are more variable. There's more variation in the weights. And so this lets us compare two different things and see which one varies more. All right, that finishes chapter 4 without using technology. Again, the last lecture we'll go over some of the ways we can do this stuff in Excel. I shouldn't say chapter 4, section 4.